Facts Hub presents Timeline of Discovery.
We are here on Earth, from billions of years, and still discovering it. From prehistory to the present day, people have sought to understand how matter behaves and to classify different types. Over the years, this has led to the discovery of new matter and materials. The earliest discoveries of how matter behaves were made not by scientists, but by prehistoric ancestors trying to survive. During antiquity, philosophers spent a lot of time trying to work out what matter is. Our ancestors learned to make fire using combustion without knowing it in 790,000 BCE. Extraction of copper from its ore by heat is discovered, and bronze is first produced by smelting copper with tin in 3200 BCE. Empedocles suggests that everything is made of four elements: air, earth, fire, and water, and Democritus suggests that all matter consists of atoms in 420 BCE. In Asia and the Islamic world, alchemists experimented to find the elixir of life and to make gold. By the late Middle Ages, European alchemists were working toward the same goal. While they are looking for the elixir of life, Chinese alchemists accidentally invent gunpowder by mixing saltpeter with sulfur and charcoal in 855 CE. Arab physician Al-Razi divides elements into spirits, metals, and minerals, depending on how they react with heat in 900 CE. Swiss chemist Theophrastus von Hohenheim works out a new classification for chemicals, based on salts, sulfurs, and mercuries in 1527. The Renaissance brought both rediscovery of antique knowledge and a quest for fresh ideas. Scientists began to test, experiment, and document their ideas, publishing their findings and working hard to classify matter. Swedish chemist Carl Scheele builds a contraption to capture oxygen by heating various compounds together. English scientist Joseph Priestley also discovers oxygen by showing that a candle can't burn without it in between 1772 and 1774. French chemist Antoine Lavoisier publishes Elements of Chemistry, which lists the 33 known elements divided into four types: gases, metals, non-metals, and earths in year 1789. Driven by the thirst for modernization, chemists identified more elements and invented ways to use them in medicine, in creating new materials, and in advanced industrial technologies. English chemist John Dalton argues that all matter is composed of atoms, and atoms of the same element are identical. He compiles a list of elements based on their atomic mass, then known as atomic weight, in 1803. French chemist Joseph-Louis Gay-Lussac experiments with gases and pressure and finds that water is made up of 2 parts hydrogen and 1 part oxygen in 1805. Russian chemist Dmitry Mendeleev arranges the 59 known elements into groups based on their atomic mass and properties. This periodic table enables him to predict the discovery of 3 more elements in year 1869. The first synthetic materials made from cellulose are invented: celluloid or moldable plastic in 1870 and viscose rayon in 1890. The discovery of radioactivity led to a better understanding of what lies inside an atom, and more research into subatomic particles. This knowledge was put to use in medicine and health care. English scientist J.J. Thomson discovers electrons using a cathode ray tube. This is the first step toward understanding the structure of atoms in 1897. Polish-French scientist Marie Curie and her husband, Pierre, discovered two new radioactive elements, radium and polonium, in year 1898. Radium is later used in radiotherapy to treat cancer. Danish chemist Søren Peter Lauritz Svendsen invents the pH scale, which is used to judge whether a substance is an acid, neutral, or base, in year 1909. The Danish scientist Niels Bohr proposes a model of the atom that shows how electrons occupy shells and orbit around the nucleus in 1913. Advances in technology allowed chemists and other scientists to invent new materials by reproducing natural materials synthetically or rearranging atoms through nanotechnology. American scientist Charles David Keeling starts to monitor the rise of carbon dioxide in the atmosphere in 1958. His Keeling curve graph is still used to study climate change. Scientists at Rice University in Houston discover a new form of carbon called Buckminster fullerene, or buckyball, in 1985. Graphene, a layer of carbon atoms just 1 atom thick, is produced at the University of Manchester, UK in 2004. It is the world's thinnest material, but 200 times stronger than steel. This is the timeline of discovery of matters till yet, but it's not an end. We are still discovering new wonders.